right? For 6 seconds. That's 6 seconds. And then it will continue move upward, but it will have a gravity. So
negative 9.8.
yeah, it will be in this phase. And how long is gonna move? So at this time point, the maximum speed, the maximum velocity will be 20 times 6 is 120. The speed here, right?
How did you do that?
Because it's acceleration 20 meter per second square for 6 seconds. So in the end, the speed is gonna be 120.
But don't we use the formula?
That's the distance, the height it traveled. But the speed here,
So the distance is what?
this phase, the distance.
What is the number? Right there? So it's 36 meters? 36 meters per second?
No, that's the distance is traveled when the motor stopped.
36 meters per second?
That's the distance. It's 360 meters high.
360 meters high. Okay.
Yeah.
So
And
when
at
we get
this-
the distance, what do we do next from there?
So when the motor stopped, the height is 360. When the motor stopped.
Right,
So-
but we supposed to use some type of formula though.
Yeah, we use formula. But in this question, we need to model it first. So there's a rocket, and then it rises vertically with an acceleration 20 meter per second square. So it will go 6 seconds with 20 meter per second square. And then here, the motor stopped, right? And here was the velocity here, when the motor stopped. When the motor stopped, because it's 80, velocity is 80, no? 20 times 6, 120. You understand here?
I understand how you did it there. From the formula.
That's the distance.
To get the distance. I
That's the
understand that.
distance. Here is also a formula. To calculate the velocity here. So you need to be able to separate this in 2 different phases. The first phase is with the motor working with the acceleration rate of 20 meter per second square for 6 seconds. And then the motor stopped. So the acceleration become negative 9.8. So that's 2 different phases you need to calculate individually. And then the first phase, in the end, the velocity will be AT. That's the formula.
Right. They want to know what is the
The
maximum height. So what is the final position?
Yes,
That's what they want to know.
yes.
And the final position would be something like y is equal to y initial times something.
So it's V0t plus AT squared. That's the formula. With the initials velocity and then acceleration.
But they have a formula for the distance too.
That's the distance. That's the distance. When you time velocity with the time, it will be the distance. Is that right?
Yeah, because they have so many, they have like, I think 3 or 4 different formulas. You have for defining the velocity, you have to find the distance,
Yeah.
and you have the formula to,
The acceleration.
I wish I would have brought my formula sheet.
Yeah, it will be easy.
But in this problem, basically, we're just trying to find what is the final position.
Final position. But you need to separate the whole process in 2 different process. The first one is with the motor working, and then the acceleration is 20. This 6 seconds. And then the second one, the motor stopped working. And then there's only the gravity. So the acceleration will become negative 9.8. And then you need to calculate the distance here. The distance here. Here is distance 1, distance 2. And distance 1, you know the initial velocity was 0. Because when the rocket it starts from 0. And then acceleration and everything you calculate, 360. At here, so the second initial velocity for D2 is AT. That is 120 meter per second. So when the motor stopped working, the speed of the rocket was 120. And here we know it's 6 seconds. But here the time will be the initial velocity divided by A2.